In this objective, for a certain radioactive isotope of atomic number Z and mass number A, the half-life is given as 50 days. And when it decays, finally it forms a nuclide whose atomic number is Z-4 and mass number is A-8. So initially when we take 1 mole of that nuclide in a sealed container and when we keep it for 100 days, we need to find out the volume of the helium gas collected at STP. Remember, when we are saying it as a volume of the helium gas collected, means it is related to the number of alpha particles emitted. Because alpha particles are nothing but double positively charged helium nucleus. So, when you see the decay process exactly from the starting nuclide to the ending nuclide, it is like this. This particular nuclide, when it emits an alpha particle, it is converted into another nuclide whose atomic number decreased by 2 units and mass number decreased by 4 units. And when this is losing another alpha particle, then only it is converted into the final product, which is Y with atomic number Z-4 and mass number A-8. It is very clear from this expression that during this decay, 2 moles of alpha particles are emitted per mole of the substance, isn't it? Because from here to here, there is a release of 1 alpha particle. Again from here to here, there is another alpha particle. Now when we come to the decay exactly, when we start with 1 mole of the substance, as its half-life is given as 50 days, in 50 days this becomes equal to half of the original amount, that is 0.5 mole, and we need to find out the volume of helium gas collected at the end of 100 days. So we need to take for another half-life, which is the same 50 days, and now this becomes equal to 0.25 mole. So the final amount of substance left after 100 days is equal to 0.25 mole. Means the amount of substance decayed in this particular time period, that is equal to initial minus final, that is 0.75 mole. So how many moles of the original substance is being decomposed, is being decayed? It is 0.75 mole. For each and every mole of this decay, how many moles of alpha particles are emitted? It is nothing but 2 moles of alpha particle. So the total number of moles of alpha particles emitted is equal to 2 into 0.75, and this becomes 1.5 mole. Here we need the volume of the helium gas, and the volume of the helium gas which is collected at STP, this is equal to the number of moles multiplied by 22.4, because we know that 1 mole of any gas at STP occupies 22.4 liters, and this becomes equal to 33.6 liters. So our answer is option D. So what we have done here, first we found out by writing this equation, we could find the number of alpha particles emitted for this particular change here to here. So for each and every 1 mole of the substance, 2 moles of alpha particles emitted. And as we need to find out the volume of the helium gas collected at STP after 100 days, and as the half-life is given as 50 days, the 1 mole of the substance originally taken after 100 days, it is converted into 0.25 mole. Means the amount of substance decayed is equal to 0.75 mole. As for 1 mole, 2 alpha particles, 2 moles of alpha particles are emitted. For 0.75 mole, it becomes 2 into 0.75, and convert that one into volume by multiplying with 22.4 liters. We get the final answer as equal to 33.6 liters.